Soil bulk density is the ratio of soil mass per soil volume. This measure tells us how heavy or dense a certain soil is. Through recent experience, we have seen that published soil bulk density figures available from the NRCS Web Soil Survey tool are very reliable. In some cases, however, tillage patterns or organic matter can change the soil bulk density over time. In this video, we will demonstrate a simplified method of determining soil bulk density for a specific location. Tools you will need are a Madeira probe or similar tool that can extract an exact volume of undisturbed soil, a hammer and block of wood, a flathead screwdriver, spray silicone or oil, a small shovel, a few quart-sized plastic zipper bags and a permanent marker, a small microwavable container, glass or ceramic is preferred, a digital scale that can measure up to 300 grams, a notebook and pencil, and a microwave. A bucket may be helpful as well, but is not necessary. Once these items are gathered, you can select a sample location. The sample location should be representative of a much larger management areas. In most production regions, one sample per foot of depth in a representative soil type is sufficient. Once the location is selected, the surface of the soil is cleared off using a shovel, and the outside of the probe is lubricated to minimize friction and soil disturbance. The probe is then carefully placed in the soil and uniformly driven to the desired depth using the block and hammer. If many samples are desired, a hydraulic sampler may be preferred. The primary objective is to extract an undisturbed core of soil. To do this, it is important to inspect the tip of the probe to ensure that it is beveled sharply to the inside dimension, not from the inside out. Be careful not to drive the probe in too far, as compaction will occur. Once the probe has been driven to the proper depth, remove the probe and core sample using the puller. It is usually helpful to twist the probe while extracting to ensure the core comes out intact. The knives are then used to isolate the sample volume of soil. In the case of the Madeira probe, the core volume is 60 cc's. The entire 60 cc's is then placed in a clearly labeled plastic zipper bag. This process is then repeated at each foot of soil profile for each representative area. The samples are then taken to a suitable working area that is not exposed to the outside elements. This is where your scale and microwave should be located. If the microwave belongs to your mother or spouse, you should obtain permission to use it for soil sampling. Your first step is to create an organized table in a notebook to mark your measurements and calculations. For this experiment, you will need a table with 6 columns. The first column is for the sample identification. The second column is for the sample volume. The third column is for the net weight of the container. The fourth column is for the gross dry weight of the sample. The fifth column is where you will record the dry soil mass, and the last column is where you will record the bulk density of the sample. The next step is to obtain a clean, dry, microwavable container and place it on the scale to obtain the net weight of the empty container. Record this weight in your notebook. You should clearly mark your containers and record their weights, as this will save time during future soil moisture measurements. Non-porous glass containers are preferred, and non-waxed paper cups are a disposable option. It is helpful to microwave the empty containers for about 30 seconds to make sure they are dry prior to placing samples in them. You can now pour the entire volume of soil into the container and place it in the microwave. If your microwave has adjustable power levels, set the power level to 7 or 8. Next, microwave the sample at this level for approximately 5 minutes. The reason we are placing the sample in the microwave is to remove the water from the soil sample. This can also be performed in an oven on low temperature, but takes a much longer time. When the sample is finished in the microwave, allow it to cool briefly and place it on the scale. This is the gross weight. Record this figure and return the sample to the microwave for an additional minute at the same power level. Again, allow the sample to cool briefly and then place it on the scale. Compare this weight to the previous weight. If they are not the same, continue to microwave in 1-minute intervals until there is no longer a change in the sample weight. Record the final dry gross weight of the sample in your notebook. We will now perform the calculations necessary to find the soil bulk density. First, we subtract the net weight of the container from the gross dry weight of the container and sample. This number is the mass of the soil in grams. You should record this mass in your notebook to 2 decimal places. The bulk density, denoted by the Greek letter rho sub b, is now found by dividing the measured mass of the soil by the volume of the core soil sample in cubic centimeters, or cc's. In our sample, the gross dry weight of the soil was 280.26 grams, and the net weight of the container was 191.80 grams. By subtracting them, we find the mass of the soil is 88.46 grams. The bulk density of the soil is then calculated by dividing 88.46 grams by 60 cc's, the volume of the soil core that we extracted. It is found to be 1.47 grams per cubic centimeter. Most soils have a bulk density in the range of 1.1 to 1.5 grams per cc, with the larger number indicating heavier clay-type soils. Since our soil sample is from a Pullman clay loam soil, our bulk density number is just about where we expected it.